we have the limit as x approaches 0 of sine 2x over sine 3x. And if we plug 0 directly in, we end up getting sine 0 over sine 0, which sine 0 happens to be 0, and then you get 0 over 0. So that's not going to work out. We need to try to rewrite this and come up with something here. Now there's going to be a trick that we're going to have to do. And math is full of all kinds of tricks sometimes. I'm going to write 3 over 3, and there's a clue right here that says I need to do that. Same thing here, because there's a 2 in here, I'm going to write 2 over 2. And let's see, what else am I going to write? I'm going to write an x over x here. And then sine 2x, rewriting this stuff here. Whoops, I want to write a sine, not a cosine. Now we're going to use the fact that I'm just going to write it up here real quick here. We have the limit, remember, of theta approaches 0 of sine theta over theta. And remember that this was equal to 1, and so we're going to use that fact right there. Okay, so we're going to scramble this stuff around, so I hope you kind of hang in there. Okay, I'm going to pair up the sine 2x and then this 2x here. I want to pair that up. So sine of 2x over 2x. So we're pairing that up, and we're going to pair up the let's see, what else are we going to pair up? Oh, we're going to pair up, forgot what I was doing there. We're going to pair up the 3 and this x together. And sine 3x. Alright, so let's see, we've used, let me highlight this stuff. Let's see, we've used this 3, this, we've used that, we've used that. Okay, and we've used this and this. So what we haven't used is, it looks like, is this 3 down here and this 2 up here. And what I'm going to do is I'm going to take this 2 and this 3 and I'm going to bring it out and get it out of the way here. And rewriting the limit. I hope you're hanging in there. This one's kind of rough. This is a typical one you might see on a test. Okay, so we know that by the what we have defined, that the sine theta over theta, and really write this number is the same as this number here for some value of x. We know that this is going to be equal to 1 as long as x is going to 0. Now, we never did talk about what happens if you flip these guys. Well, it turns out if you flip them that you're going to also get 1. Okay, and 2/3. And you're probably going, why in the world is that? Well, it has to do with the properties of limits. If I said 1 over sine theta over theta, and I was taking the limit as theta goes to 0, by the properties of limits, we could evaluate it like this. Evaluating the top and then the bottom. Okay, so this is just the properties of limits. Well, we know that this is equal to 1 and this is equal to 1, therefore it's equal to 1, right? So this is kind of the reciprocal here. If you took this and flipped it, you would end up getting theta over sine theta, right, if you simplified this down. And that's pretty much what we have up here And that's the reason that this part here is equal to 1.